Okay, today we look at this new chapter, interpolation. Okay, interpolation. What is an interpolation? I think this is new to you. Interpolation is when we are given a few set of points, okay, a few set of data points, and we want to estimate a polynomial function that can passing through all the points. Actually, we are not use the terms passing by because maybe the line is just approximately near to the given points. Okay, for example, if you have two data points, okay, if you have two data points, for example, then we will use these 2 points to estimate a straight line, okay, a straight line that passing through these 2 points. If you have 3 data points, okay, 3 data points, so we can estimate a quadratic function. Okay, so if you have 4 points, okay, 4 points, not this one, let's say here. Then we will estimate a cubic, okay, a cubic polynomial that is closely, okay, passing by. Maybe it's not, the point is not on the line, but just near to the curve. Okay, it's just near to the curve. So we want to approximate the curve that is as close as possible to the given points. Okay, that is interpolation. Okay, we just have points. We do not have the curve. Okay, we want to estimate the curve based on the given set of points. Okay, that is interpolation. Okay, so upon completion of this lesson, you should be able to determine polynomials. Okay, we will just determine polynomials, not including the exponential function, log function, all this. Okay, we will just approximate the polynomial function. Okay, using 2 different methods. Okay, the first one is Newton's divided difference. Okay, and another one is Lagrange interpolation. Okay, one is Newton's, another one is Lagrange interpolation. Okay, so once you have the function, okay, then we can estimate the value of a function for any intermediate value of the independent variable. Okay, what this means? Okay, if we have, let's say, 3 points, okay, 3 points, then we estimate a curve. Okay, this means this polynomial, let's say what we estimate is 2x squared, negative 2x squared plus 1. Then we can estimate the value of a function for any intermediate value of independent variable. Independent variable referring to the x. So no matter what is the value of x, we can estimate the value. Let's say we want to estimate what is the f function when x is 1. Okay, then you just substitute the 1 into the x, then you can get the value. Okay, we can estimate the value of the function for any intermediate value of the independent variable. Okay. Okay, now this is the flow. Okay, this is the flow. Interpolation is a method to estimate the value of a function for any intermediate value of the independent variable. Okay, this one, I think I roughly explain to you. Okay, let's say we have 3 points just now. We have x, we have fx, and here you have 0 to 4. Okay, 0 to 4. Let's say this is 1.5. This is 2.7. This is 0.5. Okay, you have these three data set. Okay, 3 points. Okay, you have these 3 points, and once you have estimate, okay, we found that this is a quadratic polynomial. Okay, then we can estimate. Okay, just like the example just now, we want to estimate the intermediate value. Okay, 1. Okay, this is interpolation. You are given a set of data. After you estimate and you get the polynomial function, then we can estimate the intermediate value theorem. Okay, we can estimate the f value for the intermediate value theorem. Intermediate value theorem, that's been those value in between all this x. Okay, you can estimate 0.1, 0.5, or 1.5. All these are intermediate value of the independent variable. So we have 2 methods. Okay, and both of these 2 methods are curve fitting. Okay, so in short, actually, interpolation is referring to the curve fitting. Okay, and we will find for the polynomial function that fits a given set of points. Okay, just a polynomial function, and then we will use the polynomial function to constructing a new data point. Okay, so here, when you get the value here, that means this is the new data point. Okay, so far, any questions?
Okay.
Yeah.
Doctor,
So,
do we have to make a graph for this?
huh?
Do we have to make a graph?
No. You don't have to sketch the curve. We just need to have a set of points. Okay, when you are given a data set in point forms, okay, then we will use the algorithm of these 2 methods to estimate for the polynomial function. We don't have to sketch the graph. Any other questions? Okay, if no, I will proceed. Okay, now we look at the Newton's divided difference interpolating polynomials. Okay, this Newton's interpolation is applicable for equally and unequally spaced data. Okay, what is mean by equally and unequally spaced data? If you have a set of points, let's say this is your x, this is your fx. Okay, you have 1, 3, 5, 7. Okay, this is equally spaced. Okay, because the difference between these 2 is 2. The difference between these 2 is 2. Okay, the difference between these 2 points is 2. Okay, this is equally spaced. Okay, equally spaced data. The unequally spaced means you have a different space for x. Okay, let's say 0, 1, and then 3, 4, and then 7. Okay, this is unequally spaced because the difference between these 2 is 1, this 2 is 2, this 2 is 1, this is 3. Okay, the difference between two x value. Okay, this is unequally spaced. Okay, this is equally spaced. So this Newton's interpolation is applicable to both of these 2 type of data set. Okay, both can be applied. Then a straight line. A straight line from Newton's divided difference interpolating polynomial that passing through. Okay, now, if you are given 2 points, okay, these are the 2 points, let's say, x0, y0, and x1, y1, you will get a straight line. Okay, you will get a straight line. And the straight line from Newton's interpolation is given by this. Okay, this is the formula for straight line under Newton's interpolation. Okay, Newton interpolation. Okay, you need to find for these b values. Okay, x naught is given by question. Okay, you must be given the points. Okay, so x naught is the point. X is a variable. You just leave x in x. Okay, this is a variable. Okay, independent variable, and you need to find for b naught and b1. So this is a straight line. Okay, this is a straight line polynomial because x is power of 1. Okay, when you expand, because this is just a constant, right? Constant times constant, you get a constant. But this constant multiplied to x, x is power of 1. So this is a straight line. Okay, this is also another constant. Okay, so this is straight line. For parabola, that means when you have 3 points. Okay, 1, 2, 3. When you have 3 points, you will get a quadratic polynomial. Okay, or we call it as parabola. Okay, parabola, a crying face or a smile face. Okay. Okay, so this is the quadratic polynomial under Newton's interpolation. Why I keep mentioning Newton's interpolation? Because you have 2 methods. The function for 2 methods are different. Okay, this is for Newton's interpolation. Okay, and this is for parabola. Okay, how do we know this is for parabola, for quadratic? Okay, we know that quadratic, x is power of 2. Okay, x to the power of 2. So if you look at this one, when you expand, you get an x squared here. Okay, x squared here. Just now, this is for your first straight line. When you are given 2 points, you just use up to here. Okay, straight line, power of 1. When you have the terms until b2, okay, this is x times x, you get an x squared. This means this is for quadratic, okay, quadratic polynomial. Okay, now we look at a general formula. A general formula of nth order Newton's interpolation that passing through the n plus 1 points is given by this. Okay, normally formula is not given. This formula is not given in any of the assessment. You have to know how to form this. Okay, so it has the b. You have to find for the b values. Okay, so if you need, okay, we look at this one first. B naught and then b1, x minus x naught. Okay, b2, x minus x naught, x minus x1. So if you have the next one, B3. Next one will be B3. Okay, B2, right? B2 and then B3. So we have x minus x naught, x minus x1, and x minus x2. This is for B3. So if you have B4, x minus x naught, x minus x1, x minus x2, x minus x3. Okay, that is for B4. Okay, so up to this term, okay, up to this term, that's mean when you have this, all this, up to here, that's mean this is the formula for the cubic, okay, cubic interpolation polynomial. Okay, cubic polynomial. So for straight line, we just take up to here. Starting from B0, we take up to here. But for the quadratic, you have to take up to here, starting from B0 up to here. Okay, if you want to find for the cubic polynomial, you have to start from B0 all the way up to this B3. Okay, so this is the general formula. Okay, you have to know how to write out the general one. Okay, for B values, we need to find the B values. Once you get the B values, that means you have successfully find for the polynomial function. Okay, any questions? The question will mention which order that it wants. If it mentions I want the first order, that means straight line. Okay, you just need 2 points. If the questions asks you to get a cubic cubic polynomial. Okay, cubic polynomial, that means you need to write up to here. Okay, the formula up to here, you need to find for B0, B1, B2, B3 for cubic. Okay, cubic polynomial. Okay, and for cubic polynomial, you need 4 points. 4 points, 4 data points. Okay, now we look at the okay, this is the derivation to get the formula, okay, on how to find for the values of B. Okay, we look at the derivation of the formula first. Okay, construct the parabola that passing through 1 point, 2 point, 3 points. Okay, you are given these 3 points. We want to construct a parabola. Okay, that means quadratic polynomial. We want to construct a quadratic polynomial, okay, based on these 3 points. Okay, and from the Newton's interpolation, we know that this is the general formula for quadratic polynomial. Okay, because up to here, this is x squared. Okay, this is x squared. Okay, so from here, we will start to find for B0, B1, and B2. Okay, we want to get a formula, okay, in order to find for the values of all this B. Okay, so derivation of this coefficient B0, B1, B2. Okay, first we will substitute the first point. Okay, we substitute the first point into x and y. Okay, that means this x, you substitute x0. Okay, x0, and here x0. When x is x0, your y will be y0. Okay, so you substitute the x0 into x, y0 into the y. Y, that means this is your y. Okay, so you have y0 here, x0 here, x0 here, and here. Okay, then here we found that this is equals to 0, x0 minus x0. This is also equals to 0. 0 multiplied to this one and this one is still 0. Okay, 0 multiplies to B1, 0. So this term is 0. And the third term is also 0. So your y0 is actually equals to B0. We have only this. Okay, that's why B0 equals to y0. Okay, B0 equals to y0. Okay, now we have already got this B0. Then to get a B1, we will substitute the second point. Okay, second point into x and y. So again, you will have y1 here. Okay, this is your x1. We substitute x1 into x now. And just now you have already got your y0. This one, the first one, b0 is y0. Okay, so we substitute what we found here. Your b0 is actually y0. So that's why your b0, we write this as y0. Okay, this is what we found just now. So now this one, x1 minus x1 is 0. That means this term is gone. So we have only these two. Okay, so here we want to get B1. So we just rearrange. This one, you move it to the left, y1 minus y0. Okay, y1 minus y0. And this term, you move it to the left. So that's why you have x1 minus x0 at the bottom. Okay, so this is how we get B1. Okay, you just rearrange. Rearrange from this equation, we want B1. Okay, we want only B1. So you move y0 first, then you move this x1 minus x0. Then you will see your B1 is equals to this. Okay, just rearrange. Okay, now we have already got B1. We want to find for the B2. Okay, so you repeat the same thing. You substitute the third point into x and y. Okay, so this is your y, y2. Substitute y2 into y. This is what we found just now for B0. And this is your B1. Okay, from here. And we substitute all the x by x2. Okay, so this one, we want to get B2. So you rearrange, move everything to the left. We want only B2. Okay, then you simplify. This one you have to do some simplification before you get this. Okay, so this is the formula for B2. Okay. So this is just to show you how we get all this formula, but it doesn't mean that you will need to memorize all this formula, even though the formula is not given. Okay, formula is not given, but we will find for the values from a table. We will use all this formula, okay, all this formula to get the values of B. Okay, so this is the table. Okay, now we look at this one by one. Where's my cursor? Here. Okay. So first of all, we will tabulate our points into this form. Okay, let's say we have 5 points. Okay, you have this 1, 2, 3, 4, 5 points. So you tabulate the points into a table where each of these 2 points you leave one line blank. Okay, leave a line blank. Okay, leave a line blank in between any 2 points. And these points, okay, all these points, it follow the sequence. Your x0, x1, x2, x3, x4 is getting larger. Okay, it's getting larger. This one must be in order. Okay, then to get the next, okay, this is the delta fi. Okay, this is your f. That means x and y. Okay, this column is the changes of f. Okay, next will be delta square of f. This is delta cube of f, delta to the power of 4 f. It will form a triangle. Okay, it will form a triangle like this. Okay, now we will look at how to get the delta of f first. So in between these 2 points, okay, in between these 2 points, we will get one value. In between these 2, we get one value. Okay, same goes to this one. In between 2, we get one value. Okay, and here. So how to get this value? Okay, actually, this one, you don't have to write this out. Okay, this one actually, you don't have to write this out. You just need to know how to get the value. Okay, to get the value, okay, remember, always use the later, okay, the later y minus the previous y value. Okay, that means here you see y1 minus y0. You use the later one minus the previous one, and you put it at the top. And from the bottom, okay, the bottom comes from x. So x1 minus x0. Okay, you can't swap the order. It must be later minus previous. Okay, then later minus previous. So this one, you put it at the top, this one at the bottom. So same goes to this. To get this value, you use this y2 minus y1 over x2 minus x1. You get this. To get this, use the later y3 minus previous y2. Okay, y3 minus y2 divided by x3 minus x2. Okay, and same goes to this one. y4 minus y3 over x4 minus x3. Okay, now you have done this column. We will proceed to the next column. So in between these 2, you will get one value. Okay, in between these 2, you get one value here. Same goes to this one. It's come from these 2. Okay, to get this, now look at my cursor. We use the later, okay, the later value minus the previous value. Okay, for the nominator, we use the later value minus the previous value from the previous column. Okay, from the previous column. Okay, use this minus this. and you get the value at the top. And the one from the bottom, okay, this one, the one from the bottom, you have to trace back to the x. Okay, you have to trace back all the way to the x. So this is x2. Okay, x2. And here, okay, this one come from here, right? So you need to trace back and then back to the x. So that's why you get x0. So you see this one, actually you will see a triangle. You see a triangle. Okay, this one, this is a triangle. And you take the x from here and here. Okay, next one, to get this, okay, to get this, you use this value minus this value, and you put it at the top. Then you see this triangle, this triangle. So the x is x3. Okay, here is x1. Okay, this triangle, x3 and x1. So that's why you have x3 minus x1. Okay, and for this one, okay, similar, apply to this. This value minus this, you put it at the top, and the one from the bottom, okay, from this triangle, that's mean x4 and x2. Okay, x4 minus x2. Okay, so next, okay, to get this value, we use this, okay, this output value minus this output value. Then you put it at the top. And the one from the bottom, so you need to trace back all the way to the y and look at the x, x3, okay, x3. And this one, trace back all the way to the y, and this is x0. So x3 and x0. That's why x3 minus x0. Okay, you will see a triangle. See, this triangle. x3, x0. Okay, and to get this, you use this value minus this divided by, okay, trace back all the way to the y. Okay, this is x4. Okay, so this is x4. And here, it trace up to the y, and the x is x1. So this is x1. Okay, and we can't stop yet because this is two values. So we need to use these two values to find for one more. Okay, so use this value minus this value, you get the value at the top. And the one from the denominator, okay, you trace back all the way, to the y. This is y4. Okay, this is y4. And here you trace back all the way to the y, you get x0. Okay, so x4 minus x0. Once you have get the last column, okay, for one value, then you can stop. So meaning that if you have only 3 points, okay, let's say you use only 3 points to get for the quadratic polynomial, so you will just compute for this. You will just compute for this. Okay, you don't need all this. Okay, because for 3 points, the table that you compute, it will just up to B2. Okay, just up to B2. Okay, and after you construct for the table, okay, remember just now your y0 is your b0. Okay, so you just take the value from the first, from the first y value, that will be your b0. And the first value from this column, this is your b1, this is your b2, b3, b4. Okay, any questions for the table? Any question on constructing this table?
No.
No. Okay, if no, we proceed to look at the linear interpolation. Linear interpolation, we need 2 data points. Okay, we need 2 data points. And what we obtain is a straight line. Okay, so you have to know that if you are using only 2 data points, okay, you will get the first order polynomial. Okay, first order polynomial, that's mean a straight line. Okay, to get a first order polynomial, this is your general formula. Okay, we just stop up to x power of 1. Okay. Then, since you have 2 data points, so this is your table. The first point, the second point, we just need to find for this. This is the triangle. Okay, to get this, you use y1 minus y0 divided by x1 minus x0. You will get the value here. And this value will be your b1. Okay, your first y value is your b0. And your x0 comes from here. Okay, now we look at one example. This one, estimate natural logarithm, that's mean ln. Okay, natural logarithm of 2, that's mean ln 2, using linear interpolation given this 2. Okay, you are given this 2. So we assume, okay, you can assume, okay, this to be your x. Okay, this is your x. And when your x change, you get your y. That means you have something like ln x equals to y. When x change, you get a different y. Okay, that's why when x is 1, y is 0. You get the first point. When x is 3, y is this 1.0986. This is the second point. Once you are given these 2 points, you construct the table, you get the polynomial function, then we can estimate for this one. When x is 2, what is your ln 2? Okay, so this is the process. Okay, so this is the first point, 1, 0. The second point, 3, 1.0986. Okay, to get this, you use this value minus 0. Okay, and then 3 minus 1. Okay, use your calculator to get this value. Okay, but of course, you need to know this one. Okay, you have to write this out first. When you have 2 points, we want a linear interpolation. That means you have to write this out, b0 plus b1, x minus x0. Okay, so your b0 will be 0. This is your b0. The first y value is the b0. Okay, so b0 is 0. b1 is this one. Okay, this is your b1. Okay, x, okay, still remain x minus x0. Okay, x0 is the first x value. Okay, the first x value, x0, okay, minus 1. So this is the estimated polynomial. Okay, this is the linear interpolation function. Okay, next we want to substitute when x is 2. Okay, when x is 2, okay, just substitute here, x is 2, then you will get this value. Okay, that means ln 2 is approximately equal to this 0.5493. Okay, this is the approximation of the ln function. Okay, approximation polynomial function for the ln function. Any questions? Any questions?
No.
Now, if you have questions, just drop the question into the chat. Okay.
I'll get at the.
Okay, next one, we look at the 3 data points. When you have 3 data points, we will estimate for a parabola, or we call it as second order polynomial function. Okay, second order, we need 3 data points. Okay, so when you have 3 data points, okay, you put them into a table, okay, where you leave a line blank in between 2 points. Okay, leave a line blank between 2 points. And you have to write this out first. For 3 data points, that means second order, x to the power of 2. Okay, this one, x to the power of 2. When you expand, you will see the x squared. So that's why we need to write up to this. Okay, B0, B1, B2. Okay, then from here, construct for the table. Okay, this value, y1 minus y0 divided by x1 minus x0 here. And for this one, use the later minus the previous divided by x2 minus x1. And the last one is you use this value minus this value divided by, you trace all the way back to y. Okay, this one, you trace all the way back to y. Okay, you get x2 here. And here you trace all the way up to y, and you get x0 here. Okay, now we look at one example. Estimate f1.7 using quadratic interpolation. Okay, given 1, 2, 3, 3 data points. Okay, so these 3 data points, you put them into the table. Okay, follow the sequence. You see your x is getting larger. Okay, follow the sequence. Okay, to get this, -3 minus 1 divided by 2. To get this, -8 minus -3. That means this will be a plus. Okay, over 4 minus 2. And last one, you use this -2.5 minus -2. Okay, minus, later you get a plus. And then you trace this back to the y. There is a 4. And here you trace up to the y. You get a 0, 4 minus 0 at the bottom. You get this value. Okay, so your first y value is your B0. Okay, this one, the first delta f is your B1. Okay, this is your B2. Okay, so you have to write this out. Okay, write this out, B0, B1, B2. Okay, this is x squared. Then substitute B0 is 1. B1 is -2. Okay, -2. Your x0 is 0. Okay, x0 is 0. And your B2 is this one. Okay, this value. X0 is 0, so you have x only. And your x1 is 2. This is your x0, x1, x2. Okay, so x1 is 2. So you have an x minus 2. So you will get this interpolation. Okay, this interpolating polynomial. And lastly, we want to estimate for this. Okay, so you just substitute the x by 1.7. Okay, 1.7, 1.7, 1.7 here. You will get this. Okay, this is for quadratic interpolation using Newton's interpolation. Clear?
Betul.
And okay,
Uh,
see, yes.
just fill the 1.7 into the x.
Huh?
Masukkan 1.7 tu ke dalam x.
This is x. This is fx.
Oh,
When
okay.
x is 1.7, what is the value of f? F is 1.
Okay.
Okay, next one, we look at the cubic interpolation. Okay, cubic, that means we need 4 data points. Okay, 4 data points. Or we call, instead of cubic interpolation, we use this term third order. Okay, third order, that means cubic. Okay, third order, that means we stop at B3 because x, we have x cubed. Okay, cubic, x cubed. Then you will construct for this table. This is your B0, B1, B2, and B3. Okay, now we look at this example. Okay, you are given 1, 2, 3, 4 points. Okay, 1, 2, 3, 4 points. We want to estimate. Okay, when x is 5.3, what is your y value or f value? Okay, so from here, 9 minus 1 divided by 4 minus 1, you get this. Okay, 13 minus 9 divided by 7 minus 4, you get this. Okay, this one also, 20 minus 13 divided by 3, you get this. Okay, next one, this one, you use this value minus this value divided by, you trace back to y, okay, you get 7. And here you trace up, you have 1, so 7 and 1. So divided by 6. And here, use this minus this divided by, this is the triangle, right? So 10, 4, 10 minus 4. Okay. And the last one, you use this one minus negative 0.2222 divided by, you trace this one back, okay? Or you look at the triangle. Okay, this is the triangle, that means 10 minus 1 at the bottom. Then you get this. Okay, so the first y or the first f value is your b0. This is b1, b2, b3. So you substitute all this b into the formula just now. Okay, you have the formula of this one, right? b0, b1, b2, b3. Okay, substitute all the b here. And your x0, x1, x2. Here, this is your x0, x1, x2. You substitute all this into the formula just now, you will get this. Okay, you will get this polynomial function. And finally, substitute x by 5.3. Okay, all x by 5.3. Then you will get the estimation. Okay, so for this one, first, you have to look at this question. You have to look at the question. It wants you to use Newton's or Lagrange because different method, you have different formulas. And secondly, you have to look at the question. It wants you to use which order? First order, 2 points. Second order, 3 points. Third order, 4 points. Okay. The question, it will either use the word order of 2. Okay, order of 2, or this one, P3. P3, that means third order. Okay, third order. So order of 2, that means x squared. X squared, quadratic, we need how many points? Quadratic, how many points we need?
3.
3, yes.
3.
Okay, then estimate 0.6. Okay, now you are given 4 points. Which 3 points that we have to choose? You look at this one. You look at the value that you need to estimate. 0.6. Where is the 0.6? 0.6 is in between here, right? 0.6. So we will take the first 3 set of points for question number 1. Okay, I repeat, when we want to choose a number of points from a given set of data, you look at this value, 0.6. 0.6 falls in between these two values, 0 and 1. So we will take 0 and 1. We will take these 2 set of points for sure. And the third point will be this one. We want to use the nearest point. Okay, the nearest point. So if you want to use, if you want to estimate f 1.7. 1.7, you want to use the first 3 points, okay, the first 3 points or the last 3 points?
The last 3 points.
1.7, yes, the last 3 points. Okay, why? 1.7 falls in between 1 and 2. Okay, and we will take this. We will take this for sure for 1.7. And in between 0 and also 3, value of 3 is nearer to 1.7 compared to 0. Okay, that's why we choose this one. We choose the last 3 points. Okay, because 3 is nearer to 1.7 compared to 0. Okay, we will choose all the nearest point to this one for the computation. Okay, now we look at the question number 1. By using Newton's divided difference interpolating polynomial of order 2. Okay, now we have already choose the first 3 points. Okay, first 3 points to estimate for this one. Okay. So question number, I sketch the table first. To I write the formula here. Okay, for question number 1. Okay, order of 2. Okay, order of 2. We will start from B0 and then B1. Okay, B1 x minus x0. Okay, next will be B2 x minus x0 and x minus x1. Okay, so B0, B1, B2. And here we have x squared. Okay, x squared. X squared, that's mean order of 2. Okay, so we stop here. We stop at B2. So we need to find for this B0, B1, B2. Okay, and we use the first 3 points. Okay, let's say here I put x, and this is fx. So the first point is 0, 10. Okay, 0, 10. 1, 8. Okay, leave a one line space. 1, 8. 1 line space. 2, 2. Okay, so this is delta f. This is delta square f. Okay, now we need to find for this one, and then this one. Your output will be in a triangle form. Okay, now I give you 1 minute. Try to get the value of this. Okay, the first delta f. Okay, what is the value? What is this value?
-2.
Yes, -2. How to get this -2? We use 8 minus 10. Okay, 8 minus 10 divided by 1 minus 0. Okay, you don't have to write this out. This is just for your own reference. You can just write out the -2. Okay, you can just write out the -2. And the second value is?
-6.
Yes, -6. We use 2 minus 8. Okay, 2 minus 8, you get -6. -6 over 1. Okay, 2 minus 1. Okay, write this up. 2 minus 8 over 2 minus 1, which is -6. Okay, and the third value? Okay, you use the later minus the previous minus, you get a plus, so -6 plus 2 divided by 2 minus 0, which is 2. Okay, so you get a -2, all right? Do you get -2?
Yeah, get -2.
Yes, good. Now we substitute. Okay, you see the first y value or f value, the first one is your b0. This is your b1. This is your b2. So you substitute all this b into the formula here. Okay, b0. b1 is -2. And then x minus, okay, x0 is the first x. Okay, this is your x0, this is your x1. Substitute them into the formula x minus 0 minus 2, x minus 0, and x minus 1. Okay, so if you simplify, you get -2x, -2x, and x minus 1. Okay, you get this polynomial. And finally, substitute x by 0.6. This chapter is covered under your midterm. Make sure you know how to get this interpolating polynomial. Okay, your midterm cover until this chapter. That means starting from the first chapter until this chapter, excluding the complex number. Okay. Here, f 0.6. So you substitute x by 0.6, 0.6, 0.6 minus 1. Okay, so you should get a 9.28. Okay, got it?
Get it.
Okay, good. Any questions? Newton's is quite simple. Compared to Lagrange, the formula is more complex. Okay, Newton's is simpler. The formula, in terms of formula, Newton's is simpler. Okay, now we look at question number 2. We want to find the order of 3. Order of 3, that means x cubed. And we want to use it to estimate this. Okay, power of 3. Okay, third order, that means we have to use all 4 points. Okay, power of 3, all 4 points. So still we are using all this. The first 3 points is the same. Okay, so I use the same table here. Okay. Then we have the last point as 3, -9. Okay, you can construct a new table, but I continue here. I use the same table here since the first 3 points are the same with the question number 1. Okay, you will get the same value. Okay, then, okay, we continue. We want to get for this value. Okay, I use red color. We want to get this, and between these two, we want to get this, and between these two, we want to get this. So this is your delta cube F. Okay, so try to get this 3 values. We use 4 decimal places. Okay, so what is this value?
-5/2.
Okay, -5.
-11.
-11. Yes, -11. We use this one, -2 divided by 1. Okay, and here,
-5/2.
-5/2. Okay, to get -5/2, we use this -11 minus -6 divided by, okay, this triangle one. This triangle, that's mean 3 and 1. 3 minus 1. So we get -5/2. Okay, then the last one, we use -5/2. Okay, this later value minus the previous value divided by, okay, this triangle. This triangle, the x value is 3 and 0. So this is -5/2 plus 2 divided by 3. Okay, -1/6. Correct? -1/6.
Yes, yes.
Okay.
Yeah, ada.
Then, wait, question number 2. Your fx will be, okay, you have to write out the formula. B0 plus B1 x minus x0. Then B2 x minus x0 x minus x1. Okay, this is cubic, so we need a B3 x minus x0 x minus x1 and x minus x2. Okay, now substitute all this B0, B1, B2, B3, and X0, X1, X2 into the formula. Okay, this is your X2. Okay, your B0. 10 minus 2 x minus 0 minus 2 x minus 0 x minus 1. B3 is -1/6 x minus 0 x minus 1 x minus 2. Okay. Then we estimate for 2.7. Substitute all x by 2.7 to get this one. To get this. Okay. Do you manage to get this 95.1156?
Madam, I dapat negative 5.1155.
55. Oh, okay. Maybe it's because of my previous calculation is based on this is negative 2.5. This is negative 0.1667. Okay. If you use 4 decimal places for this all B value, you will get this. But if you use the actual one, maybe it's slightly different. This one should be fine, right? You can use either the actual one or you can use the 4 decimal places. If this is just a very simple fraction value, okay, you can leave it in actual one. But if the value is 113/60, something like that, okay, you just use 4 decimal places. Okay. Any questions? We have done Newton's interpolation. Any questions?
No, madam.
No, all clear.
So kalau guna method lagi satu, dapat jawapan lebih kurang ke?
Yes, it will be around the same, but maybe it can be slightly different because the formula is different. Okay, but it will be around the same. Any other questions?
Not yet.
Yeah. So this is another one, Lagrange. Okay, Lagrange, this one supposed to be the next class lesson, okay, because this is for 1 whole week. Okay, 1 week within this week, you have 2 classes, one for Newton, another one for Lagrange. So now I want to know, you want to continue to Lagrange or leave this to the next class?
To the next class.
Next class.
Next class.
Next class, that's mean next week. Because this Thursday we will, as what I promised, we will do some revision for the midterm topics. Okay, so
Madam,
we will
for
give,
the midterm, what chapter will be include for exam?
starting from the first until this starting from the first chapter, okay, up to the interpolation. Okay, because you see midterm scope from week 1 to week 7, okay, up to here. Week 1 to week 7, except complex number. Okay, that's mean chapter 1, chapter 2, chapter 3, and chapter 5.
So akan ada berapa soalan, madam?
This one, I think 3 or 4. I can't remember, and I haven't get the question paper yet. Okay, but it should be 3 or 4 questions. Okay, normally 3 or 4. Okay, if there are only 2 questions, that means under question 1 it has AB. Under question 2 there is AB parts. Okay, so either 3 3 main topics or 4 main topics. But there are still 1 month time for your midterm. 1 month time, mid of December. Okay, so this Thursday, for those who haven't leave a feedback in ULearn, please leave some feedback in the ULearn. Okay, and I will just based on the topics of midterm, I will do some revision. Okay, and based on the comments from students. Maybe I will just take the tutorial questions. Have you guys done the tutorial questions from chapter 1 up to chapter 3?
Not yet.
Not yet. So maybe we will just look at some of the tutorial questions to try to explain, revise, something like that. Okay, but that's what I know. Bisection is one of the topic. Bisection method. I'm not sure how good you are in this bisection. Maybe we do some revision on this Thursday. Okay, this interpolation is also included. Okay, any more questions before we end the class? I have done marking your quiz 1, but I haven't keyed into the system. I will try to complete it by today. I tried. That's right. Any other questions?
Not yet.
Yes.
Tak ada, madam.
No. No questions. Okay, if no questions, then we end our class here. I will see you on Thursday through Microsoft Teams. Okay, we have fully online class on Thursday. Okay, so see you guys.
Okay, thank you,
Okay,
madam.
Doctor. Thank you,
Bye.
Doctor.
Thank
Thank you,
madam.
Doctor.
Thank you,
No problem.